I wasn't interested in Castleman disease research because I knew folks were doing research all around the world. But I did do a little bit of Castleman's research, and I published a case report on myself because I had noticed that I had these cherry hemangiomas, blood moles appearing all over my skin leading up to each of my relapses. So I published this case report, and so I was the first author and I was the patient. And then they also put a picture of my chest on the cover of their journal, which I think might be a medical first. Unfortunately, 15 months after I got out of the hospital, I had a full-blown relapse. All of my symptoms returned, and you can see in this picture, this is just as I'm starting to get 7-agent chemotherapy. And you can tell here I'm motivated, I'm ready for war, ready to take this thing on again. And then this picture was taken about 6 weeks later. And a lot happened during that period. Most importantly, I had a conversation with my doctor where I asked him, I said, what causes this disease to attack the way it does? Which immune cell type is driving this? What's gone wrong inside that cell type? And this is the world's expert for Castleman disease, and he said, we don't know to all of these questions. So I turned to my sisters and now wife, and I told them, I said, I'm going to dedicate the rest of my life, however long that may be, to trying to cure this disease. So when I left the hospital, I started looking to see, well, what's being done for Castleman disease? And I found that the situation was really grim. There was no diagnostic criteria, no one collaborating. There were a few advocacy organizations, but they were not active in research. There was a lot of work to be done. So then I looked to see, well, how do other foundations accelerate research? And I found that a lot of groups begin by first raising money and then inviting researchers to apply to use the money how those researchers see fit. But I thought about some challenges and some problems that we might face with Castleman disease, a disease with so few researchers that we just have to hope that the right researcher applies for the right project at the right time. And when you have the disease, you don't want to just hope about all these things having to line up. So we decided to come up with a new approach, and we called the collaborative network approach. Basically, we started by first building a community of researchers and physicians around the world through online webinars and through online discussion board and in-person meetings. Once we built that community, we sent out a series of surveys to crowdsource from that community to figure out what research questions need to be done. Once we generated a really impressive response and a number of research study ideas, we prioritized them, and then we proactively went out around the world to find who is the best person in the world to do each one of our studies. So rather than hoping that the right person applies for the right project at the right time with the right skill set, we found out what the right project was, and then we went out to find the right person to do it. In parallel, and as we make these, as we generate findings, we always look to see what drugs already exist that might have an effect on this disease that we can use off-label, that are at the local CVS that could help someone tomorrow. And we have an international natural history study so we can track the effectiveness of all of these off-label treatments. One thing I'm really proud of about our work is that this is done with the work of medical students, business school students, patients, loved ones, people like Jason Ruth, who's here with me today, who's our Chief Scientific Officer, who they have so many other things they could work on, but they volunteer their time to help us to accelerate our research. Our most important breakthrough came a few years ago when we realized that the medical community's understanding for Castleman disease was upside down. When I was diagnosed, if you read a textbook, you would learn about lymph node tumors that then turned on the immune system. But the research we did, we found out that it's actually not the lymph node tumors turning on the immune system. It's actually the activated immune system that causes the lymph nodes to grow. These are not tumors. This is reactive lymphadenopathy. And the reason this shift is so important is that before, when you think it's just tumors secreting IL-6 to turn on the immune system, you can only kill tumors with chemotherapy or block IL-6. But now that we think about it as an immune system disorder, there are a whole host of immunosuppressants that can then be tried against this disease. Now, though this is a big step for us in having the right framework, there's still a bunch of unknowns. What causes the immune system to become activated in the first place? What cell types are involved? Signaling pathways? There's a lot of work still to do. About 1 week after I submitted the paper to Blood, which resulted in the figure I just showed, all of my symptoms returned. So 17 months after my previous relapse, I had my 5th flare of this disease. At this stage, I had failed every drug that had ever been reported. I failed the only experimental drug that's now approved. And relapse after relapse was taking a toll. And I was approaching my lifetime max of cytotoxic chemotherapy. So at that stage, I decided I would pour everything I had into going through the data that we had available to me. And looking through thousands of pages of medical records and every sample that was available, I started finding a few trends. The first is that I found out that soluble IL-2 receptor levels, which is a marker of T-cell activation, was the earliest protein to rise leading up to my flare. The next thing to rise after soluble IL-2 receptor was VEGF, the growth factor that causes blood vessels to grow. And you remember I told you about the cherry hemangiomas, these blood vessels growing in my skin, something that we had observed earlier on that was fitting with this story. At the same time, my lymph nodes are highly vascularized, lots of blood vessels. So we knew there were activated T cells, and we knew there was excess VEGF, and we thought, should we target T cells? Should we target VEGF? Or is there maybe something else that we could go after? So we looked upstream. And one signaling pathway that's upstream of both T cell activation and also VEGF expression is the mTOR pathway. Fortunately, the mTOR pathway also has a drug that blocks it very well. So we stained my lymph node for phospho-S6, which is a marker of mTOR activity, and brown is positive, and my lymph node is the second from the left. And you can see that my lymph node stained blazingly strongly positive for mTOR activity. So based on these data alone, and having failed every drug that had ever been used in Castleman disease and having nearly died 5 times battling the disease, I decided to try this drug, sirolimus, an mTOR inhibitor that had never been used in Castleman disease before, but that I had some data that I thought could mean that it would work. So I started myself on it, and fortunately, today marks 42 and a quarter months. Today is 42 and a quarter months since my last relapse. In my first 42 months, I had all 5 of my flares, all 5 hospitalizations, spent over 8 months hospitalized over that window. And now in the second 42 months since I got sick, I've been in remission this whole time. Now I say 42.25 months because when you've gone through what I've gone through, you don't round down and you don't round up. It's 42 and a quarter months that I've been in remission, and we're still counting, of course. We've also now started the drug on 3 other patients who are doing well. But before we can really expand this more broadly, we are looking to do a clinical trial. I actually just submitted an R01 to try to do a clinical trial for sirolimus in more Castleman disease patients.